Good morning. Thank you for coming. To everyone on the live stream, thank you for watching. Thank you for your interest in accessibility. My name is Phil Weaver. I'm here with Qasid Sadiq and Isha Bobra. And we want to talk to you this morning about demystifying Android accessibility development. And what we mean by demystifying is there's a tremendous amount of complexity in accessibility. And sort of as part of Android, I think our job is partly to try to avoid having developers deal with that complexity. And as we looked at some of our APIs, we feel like we've maybe not done as good a job on that as we should have. So what we want to do is present some ideas here, overall idea of how we think about accessibility, and also some new APIs we've done to try to simplify your experience, and some tools we have to talk about to help you test your products. So I'm going to do a bit of a run-through of sort of our high-level opinion. Qasid's going to talk a bit about APIs, Isha's going to talk about testing, and then I'll talk a bit at the end to wrap up. So I want to start with three simple things about accessibility. I feel like, as I think about this, I personally know more than three things about accessibility. I'm working on this for close to a decade, so I maybe know like 5 things. But there's a lot of other areas where I work where, like internationalization, version control, sort of a whole range of things where I kind of know a few things. And that's kind of enough to get through like my overall workflow. And so I feel like there's probably 3 things that everybody in the world should know about accessibility that are built into their daily work. And I think the first one is very simply to make information visible. And a lot of people think about accessibility, they start thinking about screen readers and people who cannot see. And there's a lot of people in that category, and that's important. There's also a lot of people who just have low vision, or like me, are getting older, and it's harder to read small fonts. And so just making sure that your information is as visible as possible without anybody having to turn on any tools or do anything fancy with accessibility is actually one of the most common things we see people struggle with. There's a lot of designers who will kind of design something that looks really great because it's light gray on slightly lighter gray. And I think a lot of us have seen that both in designs we're trying to implement and designs that we're struggling to use, or fonts that are just too small because too much information is being crammed into a page. The other thing to think about is color. If you're using color to convey information, keep in mind that there's a lot of people out there who are colorblind, and so they're just missing the information you're trying to convey. So just in general, if you can think about how to make information visible, you can get a long ways to just reaching more and more people. The second one's sort of the complement of that, which is assuming somebody can see your UI and understand what you're trying to convey, are they able to actually use it? And that's where just simple big controls can make a big difference. I think, again, we've all had the experience of somebody who got a little carried away of just trying to add too much configurability into too small a space, and it ends up being kind of random which button you end up hitting. And for somebody with a little bit less motor control, or somebody with just really big fingers, there's a whole range of things that their experience of using UIs that maybe we don't find to be too tight, their experience can be the same as what was ours when we were sort of struggling with something that's just clearly way too close together. Just making sure that in both cases, information, big and bold, controls, big and simple to understand. And the third one really gets into sort of a lot of what often is thought of first for accessibility, which is to help users who can't see the screen. If you're using an image to convey information, after you've made it as visible as possible, also make sure it works for people who can't see it at all. And the simplest way to do that is just to label the image. And we have a very simple API that Qasid will mention that can help you do that. When you go to label things, you want to label it precisely, because you're trying to convey information, make sure that information is conveyed in the text. But on the other hand, if you think about the experience of a screen reader user, particularly if it's like a control or something they're going to go to all the time, they don't want to hear a long treatise about how exciting this particular graphic is. They really want to just get on with their day and get on with whatever action that thing can do. So you want to label things concisely. These two things are a little bit in tension with one another. So part of this is like, if you're trying to really just convey information, and that's what's in there, make sure that's conveyed as precisely as possible. If you're trying to just explain to somebody how to use something, just one word, which is a verb, is usually enough. So that's 3 things, but you may have come here to learn more than 3 things, so we want to dig a little bit deeper And just think about how users interact with your app. Much like the three things, there's essentially two things that you're doing. You're presenting information to users, and you're allowing them to take actions on your UI. So often the first design ends up being for people who sort of may not necessarily have an accessibility need, but ideally you're thinking about this up front. But then it quickly becomes kind of overwhelming. You start thinking about, okay, how's somebody who can't see going to use my app? How's somebody who's motor impaired going to use my app? How's somebody who's deaf or hard of hearing going to use my app? So now suddenly you've got maybe 4 types of users, which is your original mainstream user and then these 3 categories. But within these 3 categories, the more you stare at them, the more complexity you see. It's like a fractal. People who are visually impaired, there's all sorts of different visual impairments. People can see different levels of detail, different types of things. Motor impairments come in radical sort of variety of people out there. And then also, there are people that have combinations of these disabilities. And so, what are you supposed to do as an app developer? I mean, there's like 1 billion people in the world with a disability. Are you supposed to think through 1 billion use cases? And the answer is no, fortunately. And nobody is ever going to think through all 1 billion use cases. But with an ecosystem like this, we do have the ability to scale to that many use cases. And the tool we use to do that are accessibility services. So these are plugins to the Android platform that get information about the UI, can take actions on the UI on behalf of the user. And those developers can think about, how do I serve this particular set of users that I'm targeting? And so they're the ones that are presenting the information. If somebody can't see the screen, they're presenting it audio or braille. If somebody can't take actions on the screen directly, they may be using a switch to do it, and then these services can intermediate that. The way that they work is they get their information from the Android framework, and they use the Android framework to take actions on the UI. And so down here at the bottom is your app. In your app, just what it needs to do is present the information to the Android framework so that the framework can then share it with all these different services to support these different users. And then it needs to allow the framework to take actions on it so that all these different services, all these different users can actually get control of your app. So the way that you can do this is really to use the APIs that Qasid's going to talk about in a moment to make sure you're presenting the information and allowing users to take actions on it. And once you've done that, you can use these testing tools to verify that your app is actually working for a wide range of different users. So now let me hand it over to Qasid to talk about these APIs.
All right. Hey, everyone. I'm Qasid. I'm on the Android accessibility team. Let's talk about APIs. So as Phil mentioned, the way your application communicates what's visible on screen to the accessibility service is the accessibility APIs. But thankfully for you guys, most of the information that an accessibility service needs can already be inferred through the view hierarchy. But there are some situations where you guys actually do have to use their APIs. Thankfully, those are minimal. But let me show you what I mean. So let's just say you've made this application. And let's just say you've got this More Options button. Now, our frameworks can infer important information, like its position on screen, and that it's clickable, the information in view.java. But when a talkback user, a user who may not be able to see the screen, places their finger on this item to hear a description of this item, they're not going to get anything. And the reason is talkback really doesn't know what to say in this situation. There's no descriptive text associated with it. So you as an app developer have to step in and fill in the blanks for us. And you can do that through the Content Description API. All you do is pass in a localized string into set content description. Remember, keep the string localized, concise, and descriptive because someone has to hear it. A user has to hear it. When Phil says label your items, he means this, and for good reason, because this is most of the accessibility issues your application is going to have. And thankfully, it's trivially simple to fix. Now, our user knows that this is a More Options button, and we have a successful interaction. So let's talk about something different. Let's just say you've got this email UI. And like most inbox UIs with a list of emails, you can tap an email to select it. And you can swipe to reveal that an email is deletable. And if you continue swiping, you'll delete that email. So this is great and all, but not all users can tap and swipe on screen. Talkback users, for example, drive the UI through a completely different gesture set. Switch access users, on the other hand, they drive the UI through a series of single switches. So for these particular situations, the accessibility service, which access or talkback, need to know what actions you can perform on each item or each view in your hierarchy. Now, when a switch access user highlights a certain item as it currently stands, the user only knows that you can tap an item. And this may be because of the way we implemented that remove action or that delete action. So again, like content description, we have to fill in the blanks. And you can do that through our new Accessibility Actions API. All you do is call viewcompat.addAccessibilityAction. You pass in the view with the action, a localized string describing the action concisely to the user, and a lambda to be performed at the user's request. Now, our hypothetical switch user will be able to perform both the select and the delete action. And also, because this is an AndroidX, the library we use to backport a lot of our API, this is going to work back to API 21. OK, simple. Let's get into something a little bit more complicated. Let's talk about text and links, or clickable spans. Now, before Android O, our accessibility frameworks really couldn't handle non-URL spans well. And this is a problem, because you can imagine users like talkback users, they wouldn't be informed that there are links on screen. They wouldn't be even able to activate them. So to solve this problem, we added some API, and so they would essentially see nothing. So to solve this problem, we added some API into AndroidX. All you do for a text view which contains these non-URL clickable spans is called viewcompat.enable accessible clickable span support. Pass in the text view or the view that contains these spans. Now, our users all the way back to API 19 will know that these links exist and will be able to successfully activate them. OK. So as app developers, a lot of you like to roll some interesting custom UI. So this may look like an alert dialog, but for whatever reason, we decided to implement this using a view group, a couple text views, and a button. Now, this poses a problem for accessibility services like Talkback, because there's some information that's visually expressed about a context change happening on screen, but that actually hasn't happened. This behaves a bit like a window. So our accessibility user isn't informed about this. So the way you solve this is by treating this view group as an accessibility pane. And you can do that by calling viewcompat set accessibility pane title on the view that you consider a pane. And you pass in a localized concise string describing this pane to the user. Now, when our custom alert appears, Talkback is going to speak alert. This also works all the way back to API 19. And finally, let's say you have a video player in your application. And it's pretty typical in that it has a play button or some controls that time out and disappear after a certain period of time. And that's useful because most users just want to get to your content. They don't want to fiddle with your controls. But you can imagine an accessibility user who needs to take time interacting with your controls. By the time they're able to precisely interact with this play button, disappears. Now they've got to figure out a way to get that play button back up on screen. They've got to figure out a way to interact with it before the timeout disappears again. And this is a pretty frustrating cycle. So what we ideally need in this situation is a way to adjust our timeout based on our current user's needs. And you can do that through our new timeouts API. First, you get a reference to the accessibility manager. Then you call get recommended timeout milliseconds. This returns the suggested timeout for your view. It's customized for your view and for your user. It does this by taking the default timeout that you had planned and adjusting it based on the type of content this view is. You specify this in the second parameter. In this situation, this is a play button, and it's a control, so we pass in flag content controls. You can imagine someone with a motor disability, for example, may need this adjusted if it's a control. It also presents visual information, so we pass in flag content icons for people who may have trouble parsing visual information. If it was text, we pass in flag content text for people who have trouble parsing text. Now we've got a timeout that's customized for our view and for the current user, and a play button that works for everybody. OK, so those are the fundamentals. And let's just say you've used those fundamentals to become an expert in, or to make your application accessible. You become a bit of an expert. But you're going to really quickly discover there are some murky areas, places where it's not clear what the right thing to do is. Let's get back to this email UI. Now, let's just say you're trying to build very specifically for the talkback user, the user that can't see on screen. You're trying to determine what the experience is going to be when a new email appears. And you're trying to figure out how to express this change. And you figure the best thing you can do is by making an announcement. Every time a new email appears, announce the email. But this is a bad idea. And if you catch yourself using the accessibility event type announcement, you're probably conforming to this anti-pattern. You see, changes in the UI are expressed very differently depending on the accessibility service and the user's preferences. Services don't need fine-tuning of accessibility UI from the application. They need a generic representation of the UI that they themselves can manipulate for the users that they understand so well. So, what do you do in this situation? Well, this is what you do. That's right, you don't do anything. And you can do this by using the widgets we provide to you in our frameworks, such as AndroidX and Material. These widgets come with accessibility built in out of the box, which significantly reduce the amount of work you as an app developer have to do. So you can really focus on the very particular value that your application provides to the world. But if you really must write your own custom widgets, if you really must do it yourself, make sure you're communicating the exact semantics of the changes in your UI by using the correct accessibility events and populating it correctly. Remember, in this situation, you're not communicating directly with the user. You're communicating with the accessibility service. So, something similar that people like to do is manage accessibility focus themselves. And again, this is a bad idea. Accessibility focus is to be determined by the accessibility service. And just like announcements, this creates an inconsistency in experience. And actually, that's one of the biggest issues that accessibility users face, inconsistency across applications and over time. You see, there are a lot of applications, and if you as an app developer decide to break with the paradigms of accessibility interaction from the rest of the system, you're making your users' lives frustrating. Because now that accessibility user, every time they open your application, they've got to throw out all of their expectations in terms of how their interaction works. And they've got to relearn this whole new UI at a very fundamental level. So, the best thing that you can do for your accessibility user is to maintain consistency over time and with the system. Okay, now that you know how to fix your issues, Isha's going to talk about how to find them and how to make sure you fix them.
Thanks, Qasid. Hello, everyone. So now that we know what we are building for and how to build it, the next obvious question is, how do I know what I built is correct? Things like, is my text visible to most of the users? Or is my button large enough? Or even if my button is labeled or not? Wouldn't it be nice if someone could check that for us? Well, there are several approaches in which you can answer this question and make the testing task easy. On a high level, there are 3 approaches that you can leverage as a developer to ensure you're creating an accessible experience for most of your users. The first is automated tests. This technique requires some coding changes and is very good to detect accessibility issues at the very early developmental phases. You can run these tests alongside your existing UI, unit, or integration tests as a part of pre-submit or continuous integration solution. The next tool we're going to look at is the accessibility testing tools. These tools do not require any technical knowledge and can be run by QA teams and release managers to perform a sanity check before your app is released out in public. And the third is the manual testing, which by experience we have realized is one of the most effective ways to ensure you're creating an end-to-end experience for users with disabilities in real-world scenarios. Let's take a deep dive into the 3 techniques. Let's first talk about integrating accessibility into your existing testing code. Most of the Android accessibility testing tools are backed by the Android Accessibility Testing Framework. It is a Java library that is written on a rule-based system to evaluate Android UI constructs for accessibility issues at runtime. Remember, it's open source, so if you wish to make contributions and add checks for accessibility, please reach out to us on GitHub. So what does this framework test for? It tests for missing labels, which actually prevents users of screen readers from understanding the content within your app. It looks for small touch targets, which can prevent users with dexterity issues to interact with your app. It also looks for low contrast text and images, which impacts the legibility of your app. And it looks for other implementation-specific issues, which can actually prevent your app from sending the proper semantics to the Android accessibility framework. So that was about the framework, and we understood what the framework tests for. The question is, how do I use this framework? So we've made it really easy to integrate this accessibility testing framework into the existing testing frameworks like Espresso and Roboelectric. These are provided as an optional component, and you can use our existing test code to run these checks. As you interact with the view in your tests, these accessibility checks run automatically before proceeding. So if you're interacting with a button in your test, we look for the button and potentially the UI around the button to look for accessibility issues. For Espresso, you can use accessibilitychecks.enable to enable the tests. The result of accessibilitychecks.enable is an accessibility validator, which can be used to customize your tests. For example, you can use .set run checks from root view to increase the coverage of your tests by running them on the entire view hierarchy wherever view actions is performed. You can also call .set suppressing result matcher to whitelist known accessibility issues so that your tests are green as you fix them. It is required that you use a view action from the view actions class to perform these tests. In this example, you see the use of click action. Remember, if you interact with the view directly, you bypass the accessibility checks. For Roboelectric, you use @accessibilitychecks annotation to enable the tests. Tests will be enabled when you test will be called on the view when you call shadow view.click on the view you want to test. And much like Espresso, you can customize your test using Roboelectric's accessibility utils. So that was all about automated tests, making changes in your code, and figuring out issues, accessibility issues, at the very early development phases. Next, we're going to look at is using the accessibility testing tools. These are automated tools and do not require any technical knowledge. The first we're going to talk about is the Google Play pre-launch report. It is an automated tool that crawls your app on multiple physical devices and looks for accessibility issues so that you can fix them before launching your app. It looks for issues like crashes, performance, and now even accessibility. We've made it really easy to get accessibility test results by integrating those directly into its developer console. These checks run on all APKs released on any Play Store track. Pre-launch report is located within the Google Play console beneath release management. You can see here's a list of issues that are highlighted by the pre-launch report. These issues are clustered, characterized, and ranked by severity. Here is a detailed view of how a report looks like generated by the pre-launch report. You can see the text with the incorrect contrast ratio is highlighted, and a suggestion is provided to improve it. On the left-hand side panel, you can see the occurrences of the similar underlying issues being highlighted. For each of the accessibility findings identified by the report, there is a Learn More link which gives you a detailed understanding of the concept and provides suggestions to improve it. Yeah, that was about the Google Play pre-launch report. Now we're going to move on to the accessibility scanner. It's another app that scans your UI and looks for potential accessibility issues like missing labels, small touch targets, etc. You do not require any code change to use Accessibility Scanner. All you need to do is go to the Play Store, download the app, or visit g.co/accessibilityscanner. Launching the app will take you through the setup process. Here is an app that we've created to highlight some of the known accessibility issues. You can see a blue floating button on the UI. This is the button that appears when you switch on Accessibility Scanner. In order to scan my app, I would simply tap on the blue button while my app's UI is in the foreground. Here is an example of how a report created by Accessibility Scanner looks like. You can see the text with incorrect ratio is highlighted. It's not just highlighted, but also a suggestion to improve it is provided. You can share the reports by scanner via email or Google Drive. And if you click on the Learn More link, it opens a detailed documentation of the concept and the issue you're looking at. So that was about the automated tools. We looked at the automated tests, which required coding changes and are good to detect issues while you're developing. Next, we looked at the automated testing tools, which were the pre-launch report and the accessibility scanner. The third technique we're going to look at is manual testing. So automation is really helpful because it helps you detect issues while you're developing, but it's not a complete solution, as it comes with certain limitations. Let's look at them. If you're depending on your automated tests, and they're based on the tests that you've already written for your code, its performance very much depends on the coverage that your test code provides. Parts of your code that are not tested can have serious accessibility issues. Secondly, like any other automation, there are always chances of false positives and false negatives. We strive to reduce false positives as much as we can, but that can result in neglecting some of the legitimate accessibility issues. And thirdly, there are certain issues that require human judgment and intervention. For example, our tools can tell you that you're missing a label, but whether or not the label string is making sense to the user, is understandable and acceptable, is something that only humans can decide. So manual testing is all about understanding your users and understanding how they're going to interact with your app using assistive technology. One way to achieve this is working directly with these users with accessibility needs and soliciting their feedback. It can be done formally or informally. Another way to achieve this is using Android's own accessibility services. So testing your app with TalkBack can actually ensure that you're providing the correct semantics to the Android accessibility framework. And testing your app with switch access can ensure that your app is reacting well to the actions initiated by these APIs. At Google, we've learned that the most successful teams are those who adopt both automated and manual testing in their development process. If you want to learn more about using Google's Android's accessibility services, please visit g.co/Android accessibility. And it can also take you through step-by-step approach to testing with keeping accessibility in mind. And with that, I will let Phil come up and give some key takeaways. Thank you.
Thank you, Isha. So hopefully you found this information useful. But as you work on your app, sort of really what we're asking is for you to help us help others use your app and help other accessibility service developers help others use your app. So we've presented a few APIs here. We hope you'll use them to share UI with as many people as possible. One thing, if you've played around with accessibility before, you may be wondering, like, why are we not showing you, like, we could have gone through the details of, like, accessibility node info and accessibility event. And our goal is really to try to limit the number of people who ever need to crack that API surface open. This new API for adding actions, I think, is really important in that respect, because it used to be if you were doing something relatively minor, overriding the touch handler, it was like, OK, you did this small change, and now you've got to crack open this great big API surface and like figure out how to modify your accessibility node info. We have an accessibility action API you needed to add. You needed to go through and override a method in view. And a lot of people, like, they kind of come up against a learning curve like that, and are like, you know, I'm kind of OK with my touch handler just kind of being like that, and I feel bad about not having it be accessible, but I just don't have the time. And so we're hoping that these APIs sort of reduce that energy barrier to one line of code that's pretty straightforward. And so we hope that you'll use them. Similarly, testing for accessibility, there's all different ways to do it. We all hope that you'll go out and find a wide range of users and test for accessibility with all of those users. And I know some of you will. But again, we're trying to scale this to the entire ecosystem. And so that's why we've got these different points where if you want to just do a quick scan, we've got accessibility scanner. We've got something after you've uploaded to the Play Store, you can get a quick check for accessibility. But the more you do, the better the experience will be overall. And also, as you go through and you do this testing, and you find weird problems, and then you start thinking, like, I know Qasid said don't do this, don't add announcements, don't try to control focus, but it's just broken. Like, the only way to make my app better is by just tweaking it a little bit. Like, you find yourself sort of digging through maybe the TalkBack source code, which is online, to try to figure out what TalkBack's doing, and like, okay, how do I sort of give it the right signals that it'll do the right thing? Please realize that you probably found a bug, and it's probably our bug. And we're eventually going to fix that bug, hopefully. We'll fix it a lot faster if you tell us about it. So if you find yourself doing engineering, and realize if you're doing engineering for accessibility, you're doing a lot more than the average developer. And we need this ecosystem to work for every developer in order for it to work for every user. So if you find yourself doing engineering and you realize no one else in the world is ever going to do this, as Qasid said, you end up building something that's inconsistent with the rest of the platform, even if it's better. And so if you found something like that, please tell us. We're monitoring the AOSP issue tracker. We monitor Stack Overflow. Reach out to us if you're stuck or you're just doing something that's way harder than it should be. Because that's the only way that's the best way we can get feedback and prioritize our own work and really scale actually, you can submit AOSP. Also, if you want to just submit a code patch to AOSP, if you found a bug in the framework, I'd very much appreciate that too. But if we do the engineering, it can scale through the entire ecosystem. And so if you've got the extra cycles to do that much, to think about it that deeply, please do think about it at the level of like, how could this thing that I've figured out work for everyone? And figure out how to upstream it and reach out to us. So I started with 3 things. I'll finish with the 3 things. Just making information visible, prefer simple big controls, label images precisely and concisely. We're doing app reviews and office hours, and it was striking yesterday as people were coming up, found that most of what we're saying is essentially in these 3 categories. That really, if everybody does these 3 things, we're going to be a lot of the way there. And so speaking of that, we've got accessibility office hours and app reviews that are happening back that way. We've got an accessibility sandbox, which is, again, just outside on the other side here, that's ongoing through all of I/O. And so these are, if you've got questions to ask us, we'll also be outside. You can come find us after the talk. And if you want to just explore the world of accessibility, we've got a sandbox for you. So with that, thank you so much for coming, and thank you for your interest in accessibility.